Okay, so why did you get fired? Because you reported X bar, and they both had the same X bar. And so what happened? You didn't have a chance to give the full data. You didn't have a chance to give this data over here. So your boss looked at these numbers. He said, well, the average is the same for both of them. So he bought, or she bought, machine B. But of course, machine B is basically useless. And so it was just a waste of money, a waste of $300,000. So what went wrong? What did we only reported X bar. We only reported a measure of the center. We could have also reported, I guess, it would have been a little hard to. We could have done the median, but that also would have basically had the same problem. Anyway, we just reported X bar, and that is, we only reported a measure of the center, and these both have the same center. So what's wrong with machine B, or what's the difference between these two machines, or these two rows of data? What's the difference between the row of data A and the row of data B? So we say that it's the variation in the numbers that is different. The mean is the same, but row A, data A, has virtually no variation. Almost everything. All the numbers are very, very close to each other. On the other hand, row B has tremendous or huge variation. So that's the problem with row B, is the variation is much, much too big. So we want to develop some way to measure variation, or measure, they also call it measure spread, or they also call it measure dispersion. Let's say measure spread. Okay, so we want some way to measure the spread. So the spread in B is much bigger than the spread in A. So whatever measure we come up with, let's call it just spread, or just call it S. Suppose we call it S. So let's denote the spread in B by S sub B. And let's denote the spread in A as S sub A. Then which one has bigger spread? The measure is going to be bigger for B than for A. So we hope to find something like that. Okay? But anyway, we need some way to measure the spread of A and measure the spread of B, and then compare them and say, oh, well, we want the smaller spread, so we want machine A. So we're going to come up with several different ways to measure the spread, just like we have different ways to measure the center. We can use X bar, we can use the median, and so on. We're also going to have different ways to measure the spread. So we're going to talk about something called the range, and we're going to talk about something called the variance, which is basically the same concept as what's called the standard deviation. Just write standard D here. And we're also going to talk about something else related to, well, it's called the interquartile range. And that's related actually to the to the quartiles that we just learned about in a video or two ago. Anyway, we're going to focus though first on this one and then on this one. But anyway, the point is, like we just said, that we want to come up with some way to measure the spread of A and measure the spread of B, and somehow say that B has much more spread in its data than does A, right? The distance between pieces of elements of A is like, what's the distance between here and here? It's just 2. And what's the distance between here and here? It's just 2. But what's the distance between here and here? It's not just 2. It's 20,000. So anyway, that's the kind of thing we want to come up with some way to measure that.